Today's goal is to find inverse functions and solve for a variable. Inverse functions are functions that undo each other. So multiplication and division, or addition, subtraction, or squaring and square root. And so essentially they take the x and the y values of a relationship and they switch them. So for example, if we want to find the inverse of this function, we just take x and y and we switch them. And then solve for y. This notation, it looks like the exponent is -1. That's the notation we use for an inverse function. It's saying this is the function that will undo this function. If you want to check to see that that really works, you can substitute in some values. For example, f of 4 is 2 times 4 plus 5. 8 plus 5 is 13. But if you put 13 into the inverse function, you get 1/2 of 13 minus 5, which is half of 8, which is 4. So it's just taking the x and the y values and flipping them around. Okay, let's find the inverse function of a radical example. Find the inverse of this function. F of x is 2 root x minus 3 plus 4. Well, an inverse function essentially switches x and y values. So we just need to switch the place of the x and y values and then solve for y. Solving for y means we want to isolate the root, except possibly a coefficient, and then square both sides. On the left, I have a binomial, so I need to use the box method. At this point, you can distribute the 4 or divide by 4. So maybe I'll divide by 4 since you'll get some nice terms. Notice I divided every single one of these terms by 4. And now I'm almost done isolating the y. So I'm going to switch notations to emphasize this is the function that's the inverse of my original function, x. And that's it. Now you're going to see sometimes some related problems like this. What if I said solve the equation f of x is c given the function f of x, let's even use the same one. For x in terms of c. Now, you've seen this before, solve for x. Solve for x means that your goal is to isolate x. But this might be a little bit different. Solve for x in terms of c. In terms of c means you'll probably have c's in your answer. Breaking down the directions are really the hard part about this problem. The solving you're quite good at. And so this last thing I noticed is that we're going to solve the equation f of x equals c. And we're given a function f of x. So what that's essentially telling us to do is take this function f of x and set it equal to c. So we have c equals 2 root x minus 3 plus 4. And we want to isolate x, so let's get x by itself. Again, we're going to isolate the root, except possibly a coefficient. Our work is going to look pretty similar to our work above. I can divide each term by 4. The right is a single term because they're connected by multiplication. And I'm almost done. I almost have x isolated. And that's it. So again, I know I'm done because I was asked to solve for x, which means isolate x. In terms of c was actually a hint to say, oh, interesting, this time my answer will have c's in it, whereas in the related example, example 2, we had x's on the right side of the equation. Okay, let's do 2 more. If g of x is 2x plus 3 over x minus 5, find its inverse function, g inverse of x. Again, we just need to take our x's and y's and switch them. So we have x equals 2y plus 3 over y minus 5. This is a rational equation, so I solve by getting a common denominator. So I have xy minus 5x equals y minus 5 is 2y plus 3 over y minus 5. Now if my denominators are the same, then my numerators must be the same. If I'm solving for an inverse function, I need to get y alone, and then I'll substitute, just swap out that notation. So let's get the terms with y on the same side of the equation. Either side would be fine. I'm going to subtract the 2y from both sides. And now I'm going to add the 5x to both sides. Now I've got those y's alone, and I can just factor them out. So I have y equals 3 plus 5x over x minus 2. That's my inverse function, g inverse of x. Notice I'm using the same letter to really emphasize that this is the function that's the inverse of g. So g inverse of x is 3 plus 5x over x minus 2. And one more to practice that tricky language. We're on example 5. Solve. Let's take a different function. H of x is 2 over x minus 4. Solve h of x equals m for x in terms of m. Okay, given this function. Okay, to solve for x means we want to isolate x. That's basically our clue of what our goal is. And this, h of x equals m, is just telling us take the function h and set it equal to m. It's kind of weird, but that's okay. We have some function that we're just solving for x, which means isolating x. Now we have a heads up that we think our answer might have m's in it. That's all it's saying in terms of m. Now, this is another rational equation, so we solve by getting a common denominator. So we have, in alphabetical order, mx minus 4m over x minus 4 is 2 over x minus 4. Now that we have the same denominator, we know that the numerators must be equal. And our goal is to solve for x. In terms of m, oh indeed, we did have m's in our final answer. And that's it.